Hello there and welcome to another video on tolerance analysis. This time around we are looking at the center distance variation and how it affects the assembly of two plates which are being assembled using two fasteners. So one plate is having M5 tapped holes as shown over here, and the other plate, the orange color plate, is having clearance holes which are having the basic size as 5.4, and both of these plates are controlled with respect to their center distance, center to center distance, with this specification 50 plus or minus 0.2. So wherever these holes are located, the center to center distance should vary within this range, 50 plus or minus 0.2 on either of the plates. And we need to find out whether with these specifications, whether the two plates will assemble if they are being assembled using M5 fasteners shown over here. Will they assemble in the worst case or not? And if they are assembling in the worst case, will there be assembly shift, or will it be with assembly shift or without assembly shift? So that is what we will calculate in this video. So first let us take the plate with the tapped holes, the M5 tapped holes. So these are two M5 tapped holes and this is the specification 50 plus or minus 0.2. So this is the M5 tapped hole shown over here, and the other hole can vary within a distance of 49.8 closer to it or 50.2 away from it. So 50 is the nominal, it can move closer by 0.2 which is 49.8, it can move away by 0.2 which is 50.2. So we can create an envelope which is enclosing all the three possibilities, and the size of that envelope will be 5 plus 0.4, considering that the size of this M5 hole is 5 nominally, and 5 plus 0.4 is 5.4. So the envelope size which is required for the assembly to take place for the plate with the tapped holes is 5.4. The size of the holes required is 5.4. This is the minimum size of hole required for assembly to take place. So irrespective of the variations on the orange color plate which is having clearance holes, this is the size of hole required for the assembly to take place, considering the variations in center to center distance on the blue color plate with the tapped holes. This is the minimum size of hole required for assembly to take place. So from this itself we can find out whether we are meeting this 5.4 requirement or not. So if we go back to the drawing, over here the smallest size of the clearance hole will be 5.3. So right off the bat we know that this specification will not be sufficient to assemble all of the conditions, considering this variation on the tapped holes on the blue color plate. Hence this specification has to be 5.5 plus or minus 0.1, so that the smallest size of the clearance hole will be 5.4, which satisfies the requirement for assembling onto the plate with the tapped holes. So that is clear. This specification will lead to a state of no assembly in the worst case. But what if we try to assemble, what if we make the orange plate with the 5.4 specification of the clearance holes? So here the blue color plate is there, and then this orange color plate, that is the one with the clearance holes, is made with the 5.4 dimension, that is 5.4 is the size of the hole of the orange color plates. So what happens? Considering that the 5.4 hole moves towards the right in worst case and M5 tapped hole moves towards the left. So, or we can say 5.4 hole moves towards the left and M5 tapped hole moves towards the right. What happens? You can see that there is an interference. We will not be able to assemble the fastener within this envelope, and hence we will need to shift the orange color plate towards the right for the assembly to take place. This shift of the orange color plate with the clearance hole is called as the assembly shift. The assembly shift which will be required in the worst case for the plate to be assembled without any obstruction will be 0.2. It will be 0.2 in the worst case. In the worst case, the assembly shift will be 0.2. Now what if we want to eliminate this assembly shift once the orange color plate which is having the clearance holes is located based on one fastener? So basically the orange color plate is brought and placed on over the blue color plate, and the one of the fastener is inserted and it basically locates the two holes, and then the other fastener is inserted by adjusting the orange color plate by 0.2 or whatever that assembly shift might be based on the size of the holes which are there. So what if we don't want to have this assembly shift and we want to just locate the orange color plate based on the first hole, based on the first fastener, and then insert the second fastener without adjusting? For that, if that is the case, and if you are incorporating the assembly shift, then the size of the hole on the orange color part, that is the clearance hole, has to be increased by further 0.4 mm. So 5.4 plus 0.4, 5.8 will accommodate the variation in the location of the clearance holes, which is plus or minus 0.2. So 49.8 nearer, 50.2 away. So incorporating both, will get a larger envelope of 5.8. Hence, if the size of the clearance hole is 5.8, then once it is located, once one hole is located based on the fastener, the other fastener can be easily inserted without any assembly shift. So to avoid mandatory assembly shift, including the variation in the envelope will make the hole larger and hence will allow the assembly to take place without any adjustment. Considering these calculations, we can modify the size, the nominal size of the holes from 5.4 to 5.9, which will mean that even in the worst case, we will be able to assemble the orange color plate on top of the blue color plate by locating using one of the fasteners and then inserting the other fastener easily without any assembly shift.